The broadcast is now starting. All attendees are in listen-only mode.
Good morning and good afternoon. This is Mark Kovich. I am a System Sales Specialist for IBM. I am part of the IBM Internet of Things Continuous Engineering Organization. Thank you for joining the webinar today on Generalized Information Architecture for Managing Requirements in IBM Doors Applications. Today presenting are Shelley Eaton, Marjorie Mccormick, and Sharon Shannon of Sandia National Labs. Shelley Eaton worked at Sandia National Laboratories for over 21 years and has been retired for 2 years. She had experience with database design, data and process modeling, requirements management, GUI design, data and text mining, and technical project management. The projects she worked on included nuclear weapons, security, and manufacturing. She first used Doors in 2001 and used Doors extensively for the last 4 years of her career at Sandia. Marjorie Mccormick has been at Sandia Laboratories for 33 years. She has been involved in software development and engineering, database design, configuration management, verification and validation, and systems engineering on satellite ground systems. Owned by Telelogic, Marjorie has been a manager of a software and systems engineering department at Sandia for the past 5 years. Sharon Shannon has been at Sandia for over 30 years. She's been involved in software development, database design, verification and validation, and software quality activities for nuclear weapons, missile defense, security, and risk assessment projects. She's been using Doors for 3 years, focusing on reporting. Before we get started, I'd like to mention that you are in listen mode only and that this session is being recorded. There will be a Q&A session at the end of the presentation. I'd like to point out the question box in your control panel where there's a plus sign. You can see questions. Click on that. A dialog box will open. You can submit your questions, which will come directly to me, and we'll be accepting questions throughout the webinar. We will save your questions for the Q&A session following the presentation. You can ask questions at any time during the webinar. Since I'm hosting the presentation today from my workstation, I will not have time to check all questions during the presentation, so I'll need to read them after the presentation to our presenters to answer. We will go through each question in chronological order. If we don't have time to get to your question, my email address will be posted in the chat window during the session so that you may contact me directly at a later time. Please note that this presentation and this recorded session will be available. There are a number of different web links in the chat window currently where you can go ahead and copy and paste and into your browser and view all recordings of the past Enlightenment Series webinars. Today's recorded session will be uploaded most likely by tomorrow, but sometimes it takes 48 hours. Let's see here. Also, if you'd like to get the presentation, it's in the handout section of the control panel. Just click on that plus sign. You can immediately download the presentation and review it now or save it for your own personal archiving. I'll be sending an automated email to all registrants and attendees of the webinar, which will include the web links with the archive. And if by chance you don't get the presentation for whatever reason, feel free to reply to me. I'll be happy to send it off to you. Or if you have any further questions, you can reply to me, in which I'll be happy to forward to any of our presenters today. So with this said, Shelley's going to start the presentation. So Shelley, you may start and just tell me when to advance the slides.
Oh, thanks, Mark. Go ahead and advance the slide. Next slide. So today in the webinar, we're going to lay the foundation for generalized architecture and discuss the components of that architecture. We have quite a few examples, and so we'll also talk about lessons learned. After that is time for questions and answers. Next slide. So 2 years ago, we decided to document how we design and implement Doors projects at Sandia Labs. The result of that effort is the technical report shown here in the first bullet on the slide, and that's been published on the web so you can access it. This report is dense with information, but today we're only going to discuss a small portion of that report. We have extensive database configuration management and software engineering experiences, and that has absolutely influenced how we design Doors projects. We believe that our projects have been successful because of that. In addition, we have employed a data modeling methodology called ORM, or Object Role Modeling, and that's aided us in designing the Doors architecture. The last bullet on the slide lists a technical report that's also available on the web, and you might be interested in reading that. However, we are not going to discuss that in the webinar today. Next slide. It's been our experience that while DOORS is a requirements management system, it is first and foremost a database. And the people designing and implementing DOORS projects need to have quite a few skills, including software engineering skills. So this slide lists what we feel are needed by people designing DOORS projects. First of all, you need to understand requirements engineering fundamentals. And then database design is very important. But you also need to know the tool so you understand some of the constraints that you're dealing with and what's possible in DOORS. RPE programming and reporting, it's important to know that because that could affect your architecture. Also DXL programming and configuration management. And by that, specific to DOORS, it includes how to release reports, how to baseline, archive, requirement change management, as well as architecture change management, and of course version control for your DXL code. We also designed software processes and standards to use with DOORS. So you can see that there is quite a bit of software engineering needed for a DOORS project. If you're lacking in any of these skills or don't have much experience, we strongly suggest that you find someone with these qualifications to join your team. Next slide.
Okay, before we move to the next slide, we're getting a little bit of echo in the background and there's some peripheral noise going on, some shuffling of papers or something, so it's a little bit difficult to hear. So whatever you're doing on your end, if you can look at that, it would be appreciated that we try to resolve it. And I'm just saying this also for the rest of the attendees, because a lot of the other attendees have been submitting me questions that they're having difficulty hearing. So I don't know exactly what's happening at your end. I'm not sure exactly what's happening on your side, but just something to be aware of. I'll move to the next slide.
Okay, thanks, Mark. I'm not shuffling papers, so I don't know where the noise is coming from.
Okay.
Okay, so what is a DOORS architecture? The dictionary says that the architecture is the complex or carefully designed structure of something. So we define a DOORS architecture to include the following architectural elements. First of all is the folder hierarchical organization, the modules, the template of attributes, types, and views, reusable link modules for traceability, the security model, and of course the standards that I already mentioned. Note that the architecture is not the data content, such as requirement statements in a text object. The DOORS structure is not the same as how you would organize information in a document with titles or headings, subheadings. That's how you may organize the data content within a module. We have found that people who approach DOORS as a database to input, relate, and manipulate and output data are generally more successful in the long run than those who view it as an alternative way to create documents like you would in MS Word. Next slide. So what do we mean by a generalized DOORS architecture? We view that as a common data and relationship structure and standards. Oh, Mark, you went backwards in the slides. There we go. So we view this as a common data and relationship structure and standards that can be applied to multiple projects. It's not a one-size-fits-all structure where you have to shoehorn in your data. You might think of it as a structure that embodies concepts rather than the specific details of any particular project. A generalized architecture is a flexible structure that can accommodate future unknown data. But this is not the same as what people generally mean by customizing software or reusing code. Not every generalized architecture is guaranteed to work. It has to be well designed. So you should be able to enter and edit data content quickly and easily. You should be able to do your traces correctly and generate the needed reports. So we do have some examples to illustrate that later on in the presentation. Next slide. It's often the case that we must focus on creating an architecture for a specific project. However, there are compelling reasons for creating a generalized architecture that can be used on many DOORS projects. First of all, there's a reduction in design and implementation costs. You're reusing a proven architecture, so you don't have to start from scratch. It takes less time, and maintenance of multiple projects is less expensive and easier to do. If you have a large project and you have components that are used on another DOORS project, it's much easier to trace amongst different projects. The effort and cost of transitioning to a new tool is reduced if you ever have to do that. And of course, you can reuse DXL code. And for the end users, it's a lot easier to work on multiple projects. Next slide. So this slide lists the components of a general architecture. These are listed in bold. Like the first one, it includes projects and folders. This organizes modules in a hierarchical structure so you can do your traces. It also includes attributes that describe text, objects, and modules. Links that relate objects using a link module. And the views that display information. Next slide. So this is an example of our generalized folder structure. So we have this in a separate project. When we get a new specific project that we have to create, we go here first and we actually just recreate that structure in the specific project. So this is a case where you have to kind of know everything before you can know anything. I'm going to dive into the specifics of creating that generalized architecture by starting with this folder structure. The folders help to compartmentalize and organize modules, and they support requirements traceability. The project name is at the very top of the hierarchy. The label follows our naming standards. Notice that there are no spaces and each word begins with a capital letter. That's our choice, and we have a document that lists all of these naming standards. Let's see, next, Mark. There are 3 top-level folders. The first is _admin. We keep this section separate from the requirements. So we keep this section separate from the requirements so the information is easier to find and because the access permissions are different from the other first-level folders. We begin the label with an underscore to ensure the folder is at the top of the folder structure. Admin folders organize non-requirement modules, and some of these include the architecture change log. Anytime we make a change to the generalized architecture, we document what the changes are and why we made them. We also have auditing scripts where we run audits on the architecture on implemented projects to see if there's been any unauthorized architecture changes. And the results are stored in that folder. And then we have a template of attributes, types, and views. These templates are used on every project that we create. Next. The link sets are all kept in a link module in the second top-level folder. Again, this keeps the link sets in one place, and the access permissions are different from the other 2 top-level folders. Next. The requirements folder is the 3rd top-level folder. Our naming standards include abbreviations to minimize the label lengths, such as RQMT for a requirement. We always have a parent requirement folder partly because some of our DXL scripts apply to all requirement folders and modules. So the starting folder is requirement. In addition, access permissions may be different. Notice the requirement folders have labels with a level preceded by a number, such as 1_level. So level is a concept. It is a level of requirements in your traceability hierarchy. So these labels are meant to be replaced with meaningful labels from a specific project. The numbers force a specific order of the folders. This varying number of this folder structure supports linking from one level up to the next level for the traceability. You may have different numbers of requirement folders, but you need at least 2 levels, otherwise you don't have anything to trace. Understand what the data is, what traces you need, and the reports to be generated. In other words, do some data modeling. This will tell you how many levels you need. The playground is the next one, Mark. This is a separate project, and it's intended to support user learning. This project should not store any real data, as the access permissions may be different from the other folders. Next slide. So one of the major questions that we always get is, how many requirement modules should I have for a specific project? Well, of course, the answer is it depends. There's no set number of modules or how many objects you should have in a module. However, each folder needs at least one module for your traceability. So how many modules you have depends on the performance requirements. The more requirements you have in any one module, the slower the performance may be. It just depends on how you have architected your modules. If you have DXL attributes, of course, that's going to slow things down. I worked on one project where we had like 3,000 or 4,000 objects in one module, and it was difficult. Performance was an issue. Also, the modules, you want to compartmentalize those to support the traceability. You also need to think about what roles you have on your project. Who's going to be doing data entry, editing, and linking in what modules? So you may need to divide your modules into more. And then think about deadlines. How many people need to be working on the DOORS project right before a deadline? And of course, the sensitivity of the data is important. You might need to compartmentalize some information more so you restrict access. So we have 2 team approaches that basically we take. One is a centralized team approach. If your project has only one or just a few users accessing the data, or just a small number of requirement objects, then you may want fewer modules at any one level. However, remember, only one person can create or edit and link objects in a single module at one time. So you have to ask yourself if one person can accomplish all of the required work to meet a deadline. And again, performance issues may become a problem at some point. The decentralized team approach is where you have many people accessing the data for creating, editing, and linking. Or if the data content has differing security requirements, then you will probably have more modules. I worked on one project with over 30,000 requirements. We had many, many modules, and that was just to support that decentralized team approach. Next slide. So here are 3 examples just to illustrate the size of the project and how it can affect the number of requirement modules. The leftmost column is a very small project where you first of all have that top requirement folder, and then you might just have a handful of requirement modules. So you could be linking from one module to the next. It's just not organized into folders, and that's just fine. The middle column is for a small to medium projects. Again, the top requirement folder. And then you have 3 folders such as component, subsystem, and system. And then you might have maybe 1 to 12 modules in each folder. And then on the right side, you have a very large project where you could have many levels of requirement folders and subfolders. And you could have as many as 20 requirement modules in each folder. Next slide. So this is just another view of this folder module hierarchical structure. And Mark, I think there you go. So on the very left is a small project, again, just what I read in the previous slide. You may not be doing any linking. It just depends on your project, although I suspect the main purpose of putting requirements into doors is so that you can link for traceability. Next. Here's an example of a medium project where you have system, subsystem, and component. Notice we kept the numbers and the labels to force a specific order of these folders, and this supports the traceability. And then each module in each one of those folders actually are requirements at that same level. On the right is the very large projects where you have folders and subfolders. But you're still keeping the integrity of that traceability by having those main levels of folders. Next slide. So as I mentioned before, the requirement folder hierarchical structure supports the traceability needs of the project. This is where linking and allocating come into play. Here the blue rectangles represent the various levels of requirement folders we have seen on previous slides. This graphic illustrates concepts. So this is not a specific architecture that you're creating, but it's more conceptual. So again, we have those levels of folders, and regardless of the number of folder levels, you always want to link up the folder structure. Here you have 4 levels, and level 4 requirements trace up to level 3 using the satisfies link set. Level 3 traces up to level 2, and level 2 traces up to level 1. But they're all using the same satisfies link set. You don't have to create different link sets for each trace. Now I've worked on some projects where the product engineers wanted to link down. Conceptually that's okay, but it doesn't really work in a DOORS implementation. Think about what the source and target modules are and who will be doing the linking. For example, users who are maintaining the level 4 module requirements are the same people who should be doing the linking up to level 3. Level 4 modules are the source modules, and linking information is stored in those source modules. Allocation, however, is always done on the downward direction. Usually an allocation attribute is used to allocate downward. In this case, the allocation attribute would list the possible module names that a requirement will be allocated to. So I think that this is very easy to understand, especially with this graphic, but and the architecture is straightforward to this. When you get to your real data, you have to understand the data, and so you can determine what requirements are needed at what level in your hierarchical structure. And that can be a little complex. Next slide. To define the generalized folder hierarchy, think about your needed traces, not necessarily how any existing documents relate. Think about the reports that you need and how you're going to do gap analysis and impact analysis activities. So in the first graphic on the left is just a repeat of the previous slide. Mark, can you get the first graphic up? Go to the next slide. There we go. In the middle graphic, this is an example of a physical product folder structure where you have level 4. Mark, can you put up the middle graphic? Level 4 is the subcomponent requirements, and they satisfy level 3 component requirements, which satisfy level 2 subsystem requirements, which satisfy level 1 system requirements. And this is actually what we draw on a whiteboard with the customer to really understand how these requirements relate. The next graphic, Mark. This is an organizational hierarchical example, and it only has 3 levels. So level 3 is project requirements that satisfy provider requirements, which satisfy customer requirements. And these are actual examples of structures that we have used. Next slide. This is a more detailed or expanded view of a folder hierarchical structure with the associated requirement modules. Again, you start at the bottom and you always link up or trace up. This is what we call the standard vertical structure for tracing requirements and what we feel is ideal. I would call this graphic a traceability model. It clearly shows what modules are contained in what folders and how each module links to another. This is a map of how requirements are organized and related. And you can use this map in several different ways. First of all, just ensure that you have the modules in the correct folders. Secondly, you can ensure that you can create the needed traceability reports by following these link sets. You can show the allowable modules for allocation type for the modules. You can identify what modules are the source and target for any link set. Next slide. We've mentioned access permission several times, or what I'm generally referring to as a security model in this slide. After creating the model that we just showed you on the previous slide with the folders, modules, and link sets, we can map the roles people play and what activities they will be doing on that model. We recommend that these 2 efforts are done simultaneously throughout the design process. It's possible that your model will change because of security requirements. It may be that you have to change the direction of a link set, which will change what modules are the source and target. So I would recommend not doing that folder and module structure in isolation. Always be thinking of your use cases that you have, how people are going to use the information. So you can ensure that people are able to do the work required of them while maintaining adequate controls to prevent unauthorized reading or creating or editing requirements. The sophistication of the security models you apply to projects differ dramatically from one project to the next. In one project, everyone who has access to the Doors project may have the same permissions, while another project you could have different permissions in every single folder. Whatever security model is implemented, it must balance 2 things. People have to be able to get their work done, and you have to be able to maintain your security model throughout the life of the project. Next slide. So here's an example of a folder hierarchical structure that has included the security model. Look at the green dashed lines. This is the satisfies link sets. So this represents the traceability from the component to subsystem to system folders, to the requirement restatement folder to the customer requirement folder. Again, you're tracing from the bottom up to the top. Now look at the solid blue lines from the qualification folder down in the right bottom corner. The quality people create, edit, and delete objects in the qualification modules. They are qualifying the requirements, so they need to be able to read and link to the requirement objects. But they can't edit or delete requirement objects. In addition, the engineers writing the requirements can view the qualification objects, but they can't edit or delete the qualification objects. So this structure supports both of those use cases, and it maintains the integrity of the requirement data. This is an elegant solution to different permissions or security requirements. Think about the use case involved, and it will become obvious which modules should be the target versus the source. So folders, modules, linking, and security are all represented in this graphic. Test out the structure with examples. This includes roles, activities that the roles perform, and what activities the roles should not be able to perform. So I think next is Sharon, and she will talk about attributes, types, and views in a generalized architecture.
Next. Next slide, please. Next slide, please. Mark? Mark?
You have the next
Yes,
slide.
the next slide, this one there?
No, go back one.
Okay, there you go. I had already advanced it. So if you can try to speak as close to the microphone as possible, that would really be appreciated. A lot of the attendees are hearing a lot of echoing in the background, unfortunately. So we'll just get through it the best we can.
Can you hear me now?
Yes.
Thank you. When defining any architecture, one tool that's proven beneficial is use cases. You may want to create use cases for folders, modules, and link sets. It's also useful to create use cases for attribute and types. It's easy on the spur of the moment to just add another attribute, but there should be a significant reason for adding any attribute because of the time and effort that will be spent on that attribute throughout the lifetime of the project. And use cases will provide the justification for each attribute. The use case will also tell you who's going to enter and maintain the data in the attribute. Today we're talking about building an architecture, but consideration also has to be given to who and how the data will be entered and maintained. There should be some kind of change management process, the formality of which will depend on the size of the project. Otherwise, you may find attributes popping out of nowhere, and we've seen this, and they have cascading effects. Architecture requests and changes should also be kept in the log module in the administration folder. You may want to avoid yes or no types. A yes or no question does not give very much information and leads to an increased number of attributes in your schema and difficulties in filtering, sorting, and reporting. Instead of having a yes or no attribute for requirement, you may have an attribute named REQ type with enumerated values such as functional, design restraint, etc. You could then have an attribute for any data that might not be a requirement called non-requirement type with values such as information or figure. Next slide, please. Here are some examples of some of the attributes and types we've used in our projects. We use prefixes in our naming standards, which organizes the attributes and is helpful during programming. We use ATT to denote standard attributes, CRE to denote information that's filled in when the object is created, and we also have naming standards on the enumerated types. These attributes also live in the template module, and we use these to create new modules. They can be imported into a new module so that you don't have to worry about inconsistencies, and global DXL strips can be created for maintenance. This template would be stored in the admin folder. Next slide, please. Again, create use cases for all global views for all the reasons already mentioned. When creating views, you want to create necessary views, but remember that everything that's created will need to be maintained. Users with specific needs can create their own private views, although you must keep in mind that changes to attributes may cause problems in private views. Views are not stored in baselines. and when a baseline is opened, data is displayed in currently defined views. So it might be that deleted attribute or DXL layout columns may not work as they did when that baseline was created. Again, views are standardized, stored in our template module, and imported into new modules. Next slide, please. Now that you know what a generalized architecture is and the components of one, you can create your own architecture, put it in a separate DOORS project, use change management processes to ensure you keep the integrity of that gold copy, and then say you have a new customer and you want to create a new project for them. All you do is copy the structure into the new project, fit the data to the structure, modify the folder labels and number of requirement folders to fit, and you have a nearly complete new architecture in a short period of time. Next, please. Especially in large projects, it's important to maintain separate environments for development activities, qual activities, and production for your architecture and DXL code. As always, define and enforce coding standards and naming standards for all items in the DOORS structure. Heartache can be minimized by writing test plans for changes to architecture and DXL code. Following configuration management standards is important for change control for the architecture and data. Processes should be developed and documented for baselining, as well as any other routine activities performed against the project. Basically, a DOORS project is like any other software project, and software standards and methodologies, such as following a lifecycle methodology for design, gathering requirements, reviews, testing, maintenance, all apply for developing a DOORS project. This is, again, an area where it's helpful to have software engineers on your team. Next. To summarize some of the lessons that we learned, we need to keep the generalized architecture up to date by making global changes to it first and then updating the implemented projects. Ensure that you have a good reason for creating valid use cases, and make sure valid use cases exist to support all objects, relationships, and attributes, because anything you create, data has to be entered and maintained. So while it's easy to create an attribute on the fly, think about the consequences of people entering and maintaining that data for the life of the projects. Our company has projects, some which go for decades, maybe even up to 99 years. Model the traces. Make sure that you have a structure in place that you can actually do the traceability that's required. If you don't understand what the traceability is, it's better to find that out during design. Design the security model. It's not an add-on on the fly. We don't want to go to healthcare.com. And finally, do not code around a bad architecture, as it will exponentially compound the problem, ultimately costing a lot of money. This concludes our presentation. We have a few more minutes. Mark, do you want us to go over some additional slides, or should we go to Q&A?
Let's go to Q&A and get some questions answered. I apologize for some of the delays in advancing and switching back and forth between questions, and the slides took some time to do. There was some latency on my end, so I apologize for that. Okay, the first question I'd like to ask came early on during the presentation, and they wanted you to repeat again the advantage of setting project at the top level and have folders underneath. Would you like me to go back in the presentation to that section, or do you think you can go and answer without that?
You can go back to that slide.
Okay.
Mark, I didn't quite understand the question.
It says here, can you please repeat again the advantage of setting project at the top level and have folders underneath? So I think it was probably on this slide here. There you go.
So the project is the top folder of projects. I mean, we were supporting like 5 or 6 projects at one time, and we had to keep them separate.
Okay.
I'm not sure that answers the question.
Okay, well, the person who asked it, if you want to rephrase it, I'll be happy to ask it again here. And then here's another question, kind of lengthy, but if I need to read it twice, I'll go ahead and do so. And that is, in classic doors, the methodology is focused on a more document-based approach, module equaling specification. Moving into next generation tools, the concepts of being organized by modules is going away for a more domain approach where specification are either just reports from the database or a collection of requirements. Has your team spent any time looking at how your architecture changes when migrating to Doors Next Generation and the rest of the JAS platform, in particular, getting away from a document-centric architecture?
Mara, do you want to take that one? Oh, you're not on here. So I've been retired for 2 years, and so I'm not familiar with the latest products that Doors offers. I can talk about the difficulties with using documents to relate the information. The problem that we have had in several projects that we've worked on is that these documents were probably created decades ago, and so they have a standard set of documents, and they were not designed with traceability in mind. So if the project team members want to keep those same set of documents and still manage requirements in Doors, the documents themselves might have to be redesigned. And that is a difficult thing to do with some of the project teams that we have worked with. So ideally, what you would do is just take the entire set of information that you have, do the modeling for traceability, and generate the reports that are needed, and not look at the current document set and try to shoehorn the folders and module structure into that document set. Did that answer the question?
Well, if not, the asker can go ahead and resubmit. Next question is, where does the design fit into this model, and why is all the qualification represented by a single module?
The qualification doesn't have to be in a single module, but it's in a single folder in our example. You could have multiple folders and multiple modules. It just depends on your project. And so with the generalized architecture, that is open. The point there was that the qualification module is the source module or collection of source modules.
Next question, do your products close forever, or do they have a process for lifecycle management, for instance, in design changes?
Some of the projects we're working on lifecycle and changes, but frankly, the projects that I have worked on were in the earlier stages of the lifecycle, and I never worked on a project later in the lifecycle. Mara and Sharon, have you?
No.
But I think that the configuration management portion of this is very important to manage the changes both to the architecture and to the requirements.
Okay, next question. Which levels of source levels, and could you elaborate on those source levels?
What do you mean by source levels?
Doesn't say here. Let me get to the next question. What is the broader explanation for DXL code? Can you explain in greater detail?
The broader explanation of DXL code?
Okay, I'll take that one. So DXL code, and I believe in the next generation it's Java, although all of our projects we use DXL. It it gives you more capability within the tool. So with the basic doors functionality, you can do tracing and you can do gap analysis, but then the DXL lets you interact across modules and data in a broader way, just as you would bringing in software around anything.
I'm going to, the asker of a previous question has come back to me on a question. He's rephrased it, so maybe we can have a better understanding of it. And that is, where does the design, that is, the implementation of requirements, fit into the model? Does that help?
So I'm not sure if I understand correctly, but if he's asking how you design and write the requirements, the only aspect about the doors model that's related to that is making sure you understand the big picture structure, as Shelley had indicated. If you have system, subsystem, components, or more organizational hierarchy. As far as creating requirements, that's a different aspect of requirements engineering. So we're talking requirements management, not requirements development.
Okay. He's talking about satisfying the requirements with hardware and software, if that helps in any way.
So,
no.
Okay, so if you have both hardware and software requirements and you have at a system level, you're defining your requirements, and you might indicate some are hardware and some are software, that still is the understanding of the kinds of requirements you would have to build into your structure. We talked about having an attribute called requirements type, so you may have values for requirements type where you indicate hardware and software. But then you would, as far as saying what satisfies, you would be breaking your requirements down as you go from system to subsystem to component. Still not sure if we're hitting on what he's trying to get across.
Okay. Next question has to do with your naming of your folders. It says, why do folders such as 1_system have an underscore in the title? Is there a particular reason why? Is that just your preferred method of doing things?
That's just a preferred method of doing it. It separates the number for easier readability.
All right, I'm going to go back to another question we had difficulty answering, and she said
Mark,
that it was, yes?
Mark, I just want to jump in real quickly. We do have some folders that start with an underscore, and that's so that they will underscore when you sort comes up first. So we do use a couple of tricks, like putting an underscore in the name of a folder so that it'll come up at the top. Also sometimes put Z at the beginning of the name so it comes up at the bottom. So we do use a few tricks like that just for the readability and what we want to see at top or bottom.
I think it was on either slide 6 or 7. An example was a generalized folder slide. The slide shows top level as a project and below are folders. What is the advantage of using project at the top level versus folder? I think this may be the slide, if it's 6 or 7. Does that make sense?
So I always had difficulty understanding what the difference between project and folders are. And quite frankly, I can't remember the advantage of using a project over a folder. Mar, do you remember?
There are some permission and access reasons, and I'm going to say my brain is going blank right now on project versus folder. There are things with archiving the data, baselining, and some various reasons like that, but I will have to admit off the top of my head right now I can't remember all the reasons.
An attendee wrote in and said that he can help address this, and that is project can be archived including links, whereas folders are just for organization. Does that help?
Perfect.
Okay, great. Hey, well, thanks, attendee who wrote that. Certain levels were explained as being source levels. What is the significance of source levels versus levels that are not?
So I'm wondering if this is talking about source versus target, because when you have your links, you have a source module and a target module. Is that the question that is being asked, the relationship of a source module and a target module?
If the asker can re-ask it or send me further explanation, I'll be able to ask again. I don't know if you can answer this one. Does Sandia have a large program that supports systems engineering and your effort with that larger program? I don't know if that's confidential or something you can share with this attendee.
So Sandia does not have one large program. We have several different programs and projects across the labs, and there are various levels of focus on systems engineering. We are an engineering lab, so we do on the projects we stress engineering in different ways. DOORS was a standard for requirements management created several years ago, but how different programs and projects use it has varied, and the way we came to this generalized architecture was we were trying to push this across the labs to be a little more consistent. And I'll have to say we haven't been completely successful. There have been areas that have picked up on it and other areas that have decided they wish to do their own thing.
Okay, the panel is open. Attendees, feel free to ask a question. I can read it immediately to the presenters. In the meantime, I want to remind everyone that the webinar is being recorded. We're going to archive it on the IBM website. Everybody's going to receive an automated email from me with the web links. If you don't download the presentation right now in the handout section of the GoToWebinar control panel, you can just reply to my automated email. I'll be happy to send you the presentation in PDF form. And the good news is the Q&A session, I think, has gone relatively well as far as the audio quality. I don't know what had changed on your end, presenters, but it seems to have gotten a lot better, so I'm really happy about that. No more questions, so I think we're going to wrap up. Shelley, Marjorie, Sharon, do you have anything you'd like to say before we conclude the webinar?
The one thing I would like to say, this is Marjorie, and I didn't do any of the presenting, but the document that we based this webinar on, it has a lot more information. We had to decide what parts of it to pull out. So if some of this information was interesting to the people listening, I'd recommend going to the document because there's a lot more in detail in that document.
Okay. Okay, so the person who had the questions that we had difficulty interpreting, he's going to send me an email, and I'll just forward it on to you, and you can go ahead and review it at your convenience, and then let me know at your convenience. So, okay, we're going to go ahead and wrap up. Thanks all for attending. I look forward to seeing you on future webinars, and for our presenters, we really appreciate your support on this. We can't thank you enough. So with that said, the webinar is now concluded. Everyone have a great rest of the week, and we will see you at future webinars. Take care all, and goodbye.